Well, welcome back once again to Forecast Lab. There's a look at the dust as we saw it on Saturday afternoon here in Texas. Wasn't a whole lot of that. In fact, let's look at the surface map, and there you can see the haze in the San Antonio area. Visibility is running about 5 to 6 miles on average. So this dust was not too severe, but it did make a brief appearance on Saturday before moving up to the Kansas and Oklahoma region on Sunday. All right, let's take a look at the surface map and see what's going on around the country. We've got a very strong polar front moving through the Rockies. The tail end extends from about Kansas down to New Mexico and Arizona. And you can see there at Albuquerque, 79 degrees. That's rather cool for this time of year. Usually they're well up into the upper 80s or near 90. Also, the dry line is active, and that's running from about Dodge City down to Childress and down to Sanderson, Texas. We do see evidence of that dry line and frontal system in place due to the strong winds. Gusts up to 27, 22, 24 knots, and that's keeping our drone aircraft down, so we're not flying any pictures today. And then we got scattered thunderstorms out in the Mississippi River Valley near St. Louis and down to Nashville. Out on the East Coast, some more cold air working its way down through Washington, D.C. and Philadelphia, but it's heavily modified, and the leading edge appears to be stalling out near North Carolina. And maybe I should have drawn that out as a stationary front. It is kind of deceiving, though. Look at that temperature in New York, 74, 75, 79, but we go up to the north, and we've got this very paradoxical situation. It gets warm, and up there around James Bay, Hudson Bay, we've got temperatures well up into the 90s. Let me replot these temperatures so you can see them a little better. And the station right here, I think that's Fort Severn. They're up to 93. We got 90 right there in Quebec, and you go all the way up to Labrador, and they're up in the 80s, which is definitely unusual for this time of year. That's kind of been the case across Quebec and Ontario over the past couple weeks, but going a little further to the north, things look a little bit more seasonal there in Nunavut and Northwest Territories, where we have 60s and 70s, and maybe that's a little bit on the cool side. A good way of understanding this weather pattern is to look at the upper levels, especially looking at the hemispheric plot centered over the North Pole. So here we're looking at the 300 millibar conditions. This is up at about 30,000 feet near the top of the troposphere. What we see here is a very deep trough on the west coast. There it is right there. And we see a very strong ridge extending from the central U.S. into the Hudson Bay and Quebec region, and then downstream another trough. So that very strong built-up ridge is helping to keep a lot of warm air in place in that Hudson Bay region. And conversely, we've got a pretty cool air mass over the western U.S. So how many long waves do we have in place? Well, there's definitely a strong one there over Russia. Maybe a second one on the west coast, kind of a mixture of these two troughs. There's this one here out west. and possibly one or two out in the Pacific. So that's about 5 waves, and that's going to progress and keep the patterns moving. I don't see much of a block. Now, in terms of blocking, I'm looking for high pressure in the polar regions or very deep low pressure in the temperate regions. Any large built-up highs? No. I mean, this is a low, that's a low, that's a low, and so on. So without any big high-pressure areas up in the Arctic region or the polar regions, that's going to likely prevent us from getting into a blocking pattern, and that'll keep these troughs moving as they go west to east. So I would say we're pretty firmly in a progressive weather pattern. So now that we have a firm idea of the distribution of air masses and fronts across the U.S., let's take a little tour, region by region. In the southwestern U.S., looks pretty clear. In fact, there's an absence of low cloud throughout Arizona and California. Up north in the Salt Lake City area, we do have evidence of cool air aloft, and you can see that by the extensive altocumulus and cirrus layers there. Also, we see evidence of mountain wave activity. You can see the ripples there. Looks like scales on a fish, somewhat. And that's indicating that we've probably got some sort of flow out of the southwest across that region, and that's going to be a good indicator of the potential for clear air turbulence. In Texas, we know that the dry line is running something like that right there. Looks like there's an absence of moisture along the north end of that dry line. And then down south, where we're closer to the moisture, not really any convection, so I think we've got a capping situation. Lots of warm air in the mid-levels. And just a quick look at that surface map. Very warm in the panhandles, 100 to 104 depending on where you are. Looks like the warmest reading there is at Childress with 104. And the dry line, let's trace that down. Yep, pretty much from northwest Oklahoma to Sweetwater and down to Sanderson. Definitely lots of good moisture out ahead of that dry line. So it's got to be the cap that's keeping things from going up. Because 101 over 71, if that was April, that would certainly get you some thunderstorms. And we can check that out on the high-resolution rapid refresh. And again, I like to use dew points because I can work with the moistest air and see what's wrong. So I'm going to put this around the Altus area, maybe around Lawton, between, I guess that'd be around Snyder, Oklahoma. And we plop that right down, and we do see evidence of not a strong cap, but there is something there. And the other problem is erosion of moisture at the top of the boundary layer. We start with 72 in the low levels, but it tapers off to 60s and 50s with height. So that's going to be part of your problem there. But the Cape, yeah, certainly that's looking pretty good. So with that, with the convective inhibition being somewhat weak, I think that's good reason to actually look at the forecast and maybe see if storms might break out. So running the high-resolution rapid refresh forward, yeah, we do get a few thunderstorms breaking out. Looks like around Vernon down to Abilene, but I would expect this time of year for them to be a little bit outflowish, a little bit high-based due to the low RHs, and be strongly diurnal, since there's not a whole lot of strong flow aloft. And let's look at the air mass feeding those storms. Yeah, actually, that looks like some decent moisture depth, 2,000 to 3,000 feet. I don't really see any problems getting storms forming. Convective inhibition looks pretty low. Good instability there, but you do see the consequence of the weak flow, and there's very little helicity present. So that's probably going to give us some slow-moving outflow storms, and you can see the decapes. They're way up there, near 1900, with downdraft temperature of about 61. So, yeah, these are going to be pushing down some cold air big time. So there's probably the potential for some strong winds, but you can see the significant tornado potential is pretty much in the basement. And it looks like those high LCLs, the weak SRH, and the poor bulk wind difference are working against the environment. In short, the storms are going to put out a lot of cold air. They're going to choke the updraft to a certain extent, and they're going to form large cold pools near the ground. There's conditions in the northwest U.S. We know that that region is under the influence of a trough. That trough covers a very large area there in the central Rockies, and we see that comet cloud circulation that we had yesterday kind of form roughly like that. So this is the baroclinic zone right there, and then the cold core region is out in this area, and that's going to be close to where the upper level low or the upper level trough are going to be present. The frontal boundaries are going to be well out ahead of it, and the dry line, of course, well off to the south. So this is the warm, moist sector, bringing in the fuel for these thunderstorms here in North Dakota, and then the rest of it out west is well behind the front, and that's mostly diurnal instability and orographics. The northeast U.S. this afternoon showing a lot of thunderstorm activity in New England. This definitely has the look of a comet cloud. See that right there? So what do we have here? We've got the baroclinic zone probably out in this region here, maybe further northeast. We've got the deformation zone back here. We've got the comet cloud. The comet cloud circulation itself right in that area, the cusp, I guess is the word I'm looking for. And then we've got the dry slot. Let me outline that dry slot. That's the area of subsidence, and you can see a pretty pronounced absence of mid and low cloud, or I'm sorry, mid and high cloud in this region right here. So if we go off to the water vapor imagery, yeah, there it is. You can see that subsidence right in that region there. So very likely if you're in Virginia, West Virginia, or around the Toledo area, you're probably seeing some very deep blue sky above the low clouds. And then we'll keep going with the water vapor imagery showing the southeastern U.S. Definitely looks like lots of moisture. However, this channel is sensitive mostly to the mid and upper troposphere, not so much the lower levels. So this is telling us that there's probably lots of convective debris, very humid conditions in the mid and upper levels, and that's probably contributing to a bit of a hazy sky out in that region. And within it, yeah, you can actually see the convective elements. That's them for sure. And then just going down to that visible imagery, there it is. There's the storms from Atlanta down to Birmingham and down to Jacksonville. And as we go out west, it looks like we're seeing the influence of the subtropical ridge as it's pretty much shutting down deep cumulonimbus convection, except for a little patch here south of Memphis. Let's take a look at a skew-t in that area, maybe around Shreveport, and I will suspect it will pick up the low cloud right there, the moisture, the low-level moisture, and it'll probably pick up some of the upper-level moisture with some dry conditions in between. And we'll probably see a lot of warm air aloft. All right, so setting that down on Shreveport. Doesn't show up too much, but yeah, there's the high cloud. Maybe if I bring that further south, we can pick that up a little bit better. Yeah, it definitely gets more moist up there. And you can see the moisture down there in the low levels. I don't see a whole lot of mid-level warmth, but whatever it is, it's definitely enough to suppress convection. We'll take another skew-t there, and yeah, here we can see a little bit more of that capping. That's due to subsidence in the mid-levels, downward motion underneath that subtropical ridge, and that's suppressing the development of afternoon convection. And that's a look around the country, what's going on today. And now we're going to cover geographic essentials. I think we'll call it that, maybe our geographic moment. I think it's very important to have a very firm understanding of geography, so we're going to try to slip in some of these into our broadcasts. The Cascades, the Cascade Range, that covers a lot of the western U.S. And there it is on Wikipedia, Washington and Oregon through Northern California. And here's a map of where it's located. We see that that's kind of in the central part of Washington, extending down through the volcanic ranges, Mount St. Helens, Mount Hood, Three Sisters, and all the way to Mount Shasta, and maybe even Lassen Peak. So this is definitely a volcanic range, and out to the west we find Seattle, I'll do that in blue, and Portland, part of the Willamette Valley extending down to Salem, and then up here we've got the Puget Sound area. And then there's one other mountain range out to the west. That's going to be the Coastal Range. And then out to the east, that's going to be the start of the Great Basin area. So that's definitely a good thing to be aware of when you're forecasting out in the western U.S. So there's the Cascades right there, and that kind of segues into the Sierra Range of California. All right, I think that's about all I got for this show. We need to get this edited and uploaded. You know the drill. So let's go ahead and do that. I do want to thank Keith Frank for editing this pledge and bumping that up a little bit. Same thing for Tom Horn. And Maynard Riley, welcome to the Weathercast. Adam Brokaw, welcome. And JT as well. And if I missed anybody, just let me know. You can send an email to metlab, METLAB, at weathergraphics.com. All right, we'll see you all tomorrow. Bye-bye.